Hey everybody, this is Nick with Frost CNC, and today we're going to tackle a topic that I've been wanting to do for a long time, one that's really near and dear to my heart, and that is continuous grain cabinetry. How do we do grain matched fronts? Specifically, kind of how do we think about them? How do we choose router bits? And then ultimately, how do we get the software to do it? How do we lay them out and really achieve looks like you see on screen? Where we can do perfect grain matching, we can wrap corners, and really take matching to the next level. So that's going to be the topic of this video. There's going to be multiple parts kind of in one big long video here, but let's do it. All right, so before we get started, make sure you subscribe to this channel. Make sure you press the thumbs up and like this video. So as we go here, this is the example we're going to use. This is a floating vanity here. We are going to grain match horizontally across this filler, across these three cabinets, and then ultimately returning to the wall here with this miter fold here on the right side. And so the bit selection conversation really centers around what are the reveals. And pretty typical in frameless is to shoot for an 1/8 inch reveal between doors and drawers to end panels. And so because of that, we really need router bits that have an 1/8 inch kerf or an 1/8 inch diameter. Much like if you were doing this on a slider or on a table saw, the kerf of the blade would become the reveal and you would have a very nice grain match. We have to do the same thing with a router. If we cut this out with your normal 3/8 compression tool, let's say, and we put them back together, there's just no way that this grain is going to be perfect. And that's not really acceptable to me. And so that's what we're going to get around is we're going to actually use 1/8 inch bits. And so what bits should we be using? Well, as I've gone down this road over the years trying to figure this out, I initially started with an 1/8 inch compression bit, thinking, hey, this is going to be veneer. I need to make sure that the top and bottom are both chip free. And so a compression tool will do that. Now, a lot of companies make a compression tool that would do that. However, they break very easy. There's something about that geometry that just doesn't quite work out. And so what I found does work great is if we actually use 1/8 inch tools that are both a down cut, which you see here from Vortex, and also an upcut 1/8 inch tool here from Vortex as well. And really using both to achieve the cutout of our parts, where we're going to use a down cut tool to make it halfway through the material. That way the surface stays chip free. And then we're going to switch over halfway through the cut to an up shear, which not only keeps the bottom of the cut chip free, but also actually helps evacuate dust out of the cut. And so I should say Vortex here does not have any affiliation with this video. These are just bits that I've had great success with in the past doing this. And so now the question becomes, all right, we've got router bits. I know they're going to work. How do we get the software to actually use both bits during a cutout, right? We need to switch tools during the cutout. And so that's the next portion here is how do we set that up in the software? So I've got the optimizer open here in Mosaic, and I'm going to go up to libraries and CNC tooling. And so the first thing to make sure is that both of the tools are in here and available to you. There's generally an 1/8 inch down shear in here by default, and so I just simply renamed that tool to include the part number, and then made a copy of that tool and called it 1/8 inch up shear with the part number. And ultimately, we'll get into feeds and speeds here in a little bit, but we got to make sure both of those are in there. Okay, so the next piece of the puzzle is to make sure that there is a tool set that calls out the up shear as the cutout tool. So I'm going to go to this continuous grain tool set that I made. And you can do that here by adding the tool set, naming it what you want, and simply adding the tools in. But you can see both of those tools are in there. And the up shear tool is called out as the cutout tool. So that's what Mosaic's going to want to use to cut out all of our doors and drawer fronts. But we actually need it to use this tool first and then finish the cut with this tool. And that's where it gets tricky. You'll notice this 1/8 inch downshear tool has none of these checked. So the way that we're going to do that is to actually use an edge tool group. So I'm going to click on edge tool groups, and you can see what they are. They're essentially ways to get different tools to run around the perimeter of a door. And so I'm going to use one of these. We'll add group. I'm going to call this continuous grain. And really what I'm using this for is to actually use the downshear tool around the edge of the door before it then cuts it out with the upshear tool. And so I'm going to add that tool. The offset's going to stay 0 because I want it on the outside of the door. And I'm going to set my depth to halfway through. So it's going to go ahead and do what's in this edge tool group first once we apply this tool group to the door. Then it's going to switch to the upshear tool and finish the cutout. Now, these bits can't go 3/8 deep. And so we're going to make sure that we need, or that we go to 3/16 deep per pass. And that's ultimately going to get us through the door in 4 passes, 2 with this tool, 2 with the upshear tool. And so I'm going to control that by how I set up this downshear tool. If I go back to tool properties, I don't want this pass depth to be 3/8 because then it's going to try and do it in one shot. I want this to actually be 3/16 because that is ultimately going to then control that it will do that in 2 passes instead of just 1. And so there's a proper setup for our 1/8 inch tool, 3/16 deep. And these feeds and speeds are pretty close to what Vortex would recommend, but this is kind of tried and true. Over time, I've had really good success with this feed and plunge rate. Okay, so if we apply this edge tool group to our doors, we now see it's going to go ahead and take out 3/8 of the material with this tool. Then it's going to switch over to the cutout tool, which is our upshear tool. Let's take a look here. You can see for this pass depth, I've got 9/16. And that's key because 3/8 of that material is already gone. So by the time it picks up this tool, I want the software to think that it can go another 3/16 from there, or 9/16 total. And so the third pass around this door is taking another 3/16 off. Then it'll go ahead and finish the cut for our 4-pass cutout. And so that 9/16 is key. And you can see this feed and plunge rate is also the same. And so that particular setup between that edge tool group, which is going to do the first 2 passes around the door with the downshear tool, and then ultimately the way the upshear is set up with a pass depth of, a pass depth of 9/16, ultimately then takes over and does the 3rd and 4th pass around the door, and we have perfect door cutouts with perfect reveals. So the next thing we're going to get into now is ultimately how do we assign that edge tool group to our doors, and then we'll get into the layout of the door and drawer fronts as well. So we're back over here on the Mosaic side. We're out of the optimizer, and here's our floating vanity that we're working on. And so what I'm going to do, and I guess here's the plan view of our 3-cabinet vanity. The first thing I want to do is I want to assign that edge tool group that we just made. So if I go back to the settings here, and I'll go to door and drawer fronts, you can see I've got this slab door horizontal here and drawer slab horizontal. And you can see I've got this outside edge option. And that's where I'm going to go ahead and pick this continuous grain edge tool for each one. Now we don't have a wall door in here, so I'm going to skip that one. And so that right there is what's going to cue Mosaic to use that downshear tool to start cutting out the door, and then ultimately using the upshear tool to finish the cutout. So we'll do that. Now also, that's just door and drawer fronts. If we're also going to be cutting some panels that might have to grain match, we're going to go ahead and do that too. So under slab door here, for our base cabinet, we're going to choose that as well. And if we had walls and talls, we could do the same thing there. And so that's how we're going to cue Mosaic into using the downshear tool for part of the cutout. We're going to pop back over here to products. And let's go take a look at our 3 cabinets in elevation here. There's the front. And so Mosaic does have a nice grain match feature that we can at least tell these 3 fronts on cabinet 1 that they are going to be grain matched together, and it will group them together when we go lay them out. And so we're going to do that on these 3 cabinets. We'll go edit here in info. And I'm going to use the horizontal grain match because this is horizontal grain. And what that's going to do is it's going to keep these 3 fronts together when we go nest them and start to lay them out. And so we'll do that on all 3. However, while I'm in this cabinet, I'm going to show something here. And this is why I really like doing this in Mosaic is I'm using a pretty unique drawer box here where I'm using Cabinetry to actually put the box together and assemble it. And that requires 5mm holes in my drawer fronts. And so you can see in the back of these drawer fronts are these 5mm holes. And so I want all of that machining in there when I do this layout. And so that's why it's really important to me to keep this in Mosaic and not simply do a layout in CAD or something like that. Because I've got a lot of machining in the backs of my doors and drawers, hinge cups, and then ultimately these 5mm holes. And you'll see that when we get over to the layout. So there's the horizontal grain match. I'm going to go to cabinet 2. I'm going to do the same thing. And if I take a look at cabinet 2, you're going to see that I'm going to have my hinge cups in the backs of the doors. And so the CNC is going to bore those as well. And then cabinet 3 is really just the same as cabinet 1. We'll go ahead and go horizontal here. Okay, so those are all set. Now let's take a look at the miter folds here. So if I take a look, I've got an L-shaped fold here. Now, if I was going to actually grain match here, right, this would just be the face of this piece, and it would grain match across the front of the drawers here. And so I'm actually not going to cut it out like this. I'm actually just going to cut a front piece and possibly the return if I have enough room on the sheet. And so ultimately when I get to the optimizer, I'm actually going to delete this part and add my own part to cut out. But let's look at the other side. So I want the grain, so I've got a J fold in here, which I do like. But I want the grain to run across the drawers here, across the face of this filler, and then ultimately back to the wall. And so we actually can't have this return in this layout. We have to do that another way. And so really what I need to do here is replace this J. If I go to the miter fold library here with an L. And I'm going to get this sized right. Get it in place. And then get the depth right here, 21 7/8. No scribe here, but that looks good. And so now you can see, and they're off a little bit here just because my material here is not 3/4 thick. But now the grain is going to wrap right across the face here and ultimately back. And then for the return, again, I'm just going to have to either find a piece on the sheet to kind of cut a 4-inch return and then miter that on at a saw, or simply butt the return and maybe veneer that. Or some shops actually just edge band this edge and then leave a little shadow back here. So there are a lot of ways to do that. But the point being is now we're set up to have the grain run and match really nice. So I think we are ready to actually optimize and lay out our pattern. So let's do that. I'm going to go to cut list here. You can see I've got 3/4 rift oak called out here with all of my pieces. So let's go optimize and let's see what this looks like. Okay. There we go. So there's my material, my thickness, my size. Let's go take a look at the parts. You can see a lot of my parts show up with flip operations called out, and that's because I have all these operations to attach the drawer fronts, and I also have hinge holes. And so I'm going to need to flip a lot of these. So let's do that. You can see when I click on these, it actually highlights the whole cabinet's worth of parts, and that's because of the grain match feature that I turned on. And so I'm going to click on that one. We're going to flip that group over. I'm going to click on this one, which is cabinet 2. We're going to flip that one over. And then group 3 here, we're going to flip that one over as well. You'll notice too that my miter fold is not actually in the correct orientation. If we're doing horizontal grain, this actually needs to be rotated. And I'm going to go ahead and rotate it 270 degrees. So then ultimately it's in the correct orientation, and you'll see that here in a second. And then this one, miter fold base, I said I wasn't going to actually cut it this way, and so I'm actually going to remove that. And I'm going to add my own part here. And so we'll call that filler left. And since it's horizontal grain, I'm going to make this a 2-inch by 24. Gotta flip-flop those. Okay. Now, 2 inches is fine. This is not getting cut out really aggressively, and so a 2-inch part actually will hold down pretty well doing this. So let's go lay it out. So I'm going to go optimize here. What's key here is that we have our part spacing set to our kerf, right? That is our reveal. That is what we want. So go ahead and change that if yours doesn't say that. And then we need to select the continuous grain tool group that we made. And there it is. And then we've got to go to cutout options here. And what's really key is that we turn off small part handling. Because if we keep that on, ultimately it's going to take 5 passes, whatever your skin or your tabs are, to cut out your parts. And so we really don't need this extra small part handling in here. All right. Let's press optimize and see what we get. All right. It's not in order, right? Our layout did not work very well. And so we can start moving them around, but we can actually do better than that. And so I'm actually going to do this. Now keep in mind, we're looking at this upside down, right? Because all of my machining is face up now. So if I actually look at the sheet, you can see how our hinge cups and 5mm holes and all that are, and the miter line are face up. And so we got to think about this layout kind of left to right, but also upside down. So really filler, cabinet 1, cabinet 2, cabinet 3, and then our miter fold filler, or our miter fold panel over here. All right. And so I'm going to start laying this out using the bump left and bump down feature. And so we'll right click on it, bump left, bump down. And so I'm going to start placing my first part. Now the next question becomes, well, hey, what if I want to start this not, in this case, 1/4 and 1/4 in? I can do that. I can go back to material and I can type in a new width trim and a new length trim. So let's say I wanted this 1 inch up on the sheet, and let's say I wanted this pattern to start, I don't know, 1.5 inches in from the left on the sheet. Even though I didn't optimize with these trims in, I can still use them. So now if I go back, and we'll do bump left, bump down again, you can see it absolutely is honoring those new spots. It's pretty cool. All right, so there's their filler to the left. Let's do number 1 here. Bump left, bump down. And we can go on that way. However, there's an issue. If I go look at this in 3D, and we're going to go to the top, you can see that this is actually the bottom of my cabinet, and it does not line up with the bottom of my filler. And that's an issue. That's how it was drawn. And so the reason that's happening is just really how we designed it. If I go back and look at the cabinetry, you can see my filler is up tight to the counter, and I've got that 1/8 inch reveal here. And so we need to make sure we move that pattern on our sheet by 1/8 of an inch to accommodate that. Let's pop back over to the optimizer. And so instead of bump left, bump down, where this is, I actually need to change the width trim to include that 1/8. And now the next time I use bump left, bump down, now we're tight here, and I can show that again in 3D here. Now we're good, and there's our reveal to the counter. And so I'm going to keep that 1 1/8 for the next one, which is cabinet 2 here. So we will bump left, bump down. Next one will be 3. We'll bump left, bump down. And then our miter fold. Now this one needs to go back to 1/8 lower than this one. And so I'm going to go ahead and change my width back, like so. And now bump left, bump down. Should get me the perfect orientation. Take a look. Perfect. So if I take a look at the front side, should look just like my elevation and ready to fold over and grain wrap around the side. So let's G-code this and take a look. I'm going to generate G-code. We've got our continuous grain tool set, and I'm going to hit calculate. And we're going to prove that it's working. So got some drill operations here. Let's go ahead and look at the 1/8 inch first. And you can see that it's doing that on our door and drawer fronts. And if I go ahead and simulate, it should take 2 passes around. There's path number 1. And there's path number 2. And then it should move on to the next. So that's working perfectly. You can see we've got our miter line here. And then you can see our final cutout where it switches to the upshear tool. So if I press simulate here, we should see this take 2 passes, which would then ultimately be completely cutting out the part. And then moving on. And you can see it does just that. So it's working perfectly. However, I think you can see one issue here, and I did this on purpose to show how we can fix it, is it's not doing our 1/8 inch downshear tool on our miter folds, right? We need that to be cut out just like a door would, and it's not doing that. You'll notice that my added part isn't doing that either, right? And so that's really the last piece of the puzzle, is to make sure we have items that from Mosaic trigger this 1/8 inch downshear to do its 2 passes first. And so I'm going to go show you how to update your miter folds to do that. And you should be doing continuous grain in no time. All right, so I'm back at my elevation. And this L filler over here, this miter fold needs to be modified, and so does this one. And so we'll start here. I'm going to go ahead and edit this. Now, what's key here is that we need a part that Mosaic thinks is a door. And so the way I'm going to do that is I'm going to go to parts to build. And you'll notice these miter folds aren't building any native Mosaic parts. The part that's actually being machined has been a custom added part with the miter lines and made parametrically. And so what I'm going to do actually is go to parts to build. I'm going to turn on the right end. You're going to see the right end show up in this list. If I go to the shape tab and go to the right end, I'm going to go ahead and call this panelized end. That's going to trigger Mosaic to think that this is a door or an applied door, panelized end, and cut it out as such with our continuous grain edge group. And so panelized end, if I go back to parts, you can see now it thinks it's a door, and it's going to cut it out of our oak material. And so I actually don't need this part in here anymore. So I'm going to go ahead and press rebuild, and that will delete custom added parts. And so the reason I did it right in here is that it'll still show ultimately what I'm trying to make, but now I'm just going to size the front piece that I want and get the return out of another spot on the sheet. And so I don't want this to be 5 wide. I'm going to edit that, and I'm going to change that to the overall width, which should be 1.5 inches, plus my scribe amount. So I'm just going to add a 1/2 inch here. There are a few ways to do this, but that's how I'm going to get my 2-inch part out right there. Go ahead and press OK. And now I'm going to save this as the continuous grain front only in my library. That way I don't have to do this again next time. This will be ready for me. So there's that one. So let's go edit the miter fold over here. And so I'm going to edit that. And this one I'm going to do a little differently. I'm going to go to parts, and I'm going to edit the part that's here. And ultimately I'm going to save it back to the library when I'm done. But I'm going to press edit here. And I'm going to edit the operations. And what I'm going to do is I'm actually going to add a perimeter toolpath. And then we're going to have that 3/8 bit follow that, and ultimately have this miter fold be cut out just like our doors will be. And so I'm going to add that toolpath, and I'm going to call it a perimeter toolpath. And so there it is. It's going to stay locked on the outside edges of the door. And here it is down here. I'm going to click on number 1. Now, here's the bummer, but there is a workaround. Is I'm going to select, and I would love if the edge tool groups are right here. I could pick the one that I've already made. But you'll notice only panel tool groups are available for us to choose. And so what I'm going to do is I'm going to go make a quick panel tool group that's the same thing as our edge tool group, and I'll be able to use it here. So I'm going to press cancel. We're going to come back to that toolpath. We'll go back to the optimizer. We'll wait a second for this to open up. I'm going to go to libraries, CNC tooling. I'm going to go to panel tool groups and add one. I'm going to call this continuous grain as well. Okay. I'm going to grab that downshear tool. I'm going to add that. Change that depth to 3/8. And there we go. So it's on the outside of the line, and literally the same thing. And now we can go ahead and use it where we just were with our miter folds. So let's press OK. I'm going to close the optimizer. I'm going to go back and edit this. We're going to go to parts and edit that miter fold, edit the operations. There's our perimeter toolpath right there, 0.1. Now if I go select, panel tool groups, boom, there it is. And so now that miter fold can be used in a continuous grain sequence, just like a door. I'm going to press OK here and here as well. And I'm going to save that as base right continuous grain. Now you'll notice I didn't really specify horizontal or vertical. And I could, I could simply make a horizontal and vertical one in the library. But I actually have no problem rotating these as needed in the layouts. So I'm just going to keep it as a generic one here. So we'll press save to library. Okay, so that's that. I'm not going to go do the second layout, but I know that those fillers and that side panel will now work perfectly. So it took me a while to put this video together. Hopefully you guys find it helpful. But that's how you achieve true perfect grain matching with a CNC router and Mosaic. We'll see you on the next video.